Okay, so when we do our notes, we're going to use 2 pages for our notes, okay? And we may do things a little differently, different times. I may have you reflect upon what you know about what we're going to talk about and write it down. The standards we're talking about right now are not 8th grade standards. So I'm not going to write a standard down, but we will be in the habit of writing a standard. And basically your format will look like this. So here's your 2 pages, and so today you're page 3 and you're page 4. So this is where we would write and you don't need to write this, but just so that you see this, you would write your standard, and we'll write it out, would go first, and then you would write what your objective is for today. So what are you hoping to learn through this lesson? And then we're going to either write some things or we're going to do vocab. And so for us today, we're going to do vocab over on the right side. And then I'm going to give you a nice little chart, and then we're going to actually put numbers into that chart. Okay? So that's what we're going to be doing. I'm going to erase all of this. Go away, all of you. I think one of these goes all of them. I can't remember which. So here's what we're going to do. We're going to focus in on page 4, and we're going to give this a title. So we're going to call this the Real Number System Review. And I do want you on the same line to put today's date. So you're 9/15. And what you're going to be doing in your table of contents is you're going to write the number 1 and the first line you can. Across, you're going to write the title, Real Number System Review, and you're going to put the date. And you're going to put the page numbers at the very, very end. Okay? So, put number 1 on the left of the red line. Then you're going to write the Real Number System Review. Okay? So, title goes on the title part right here. This should be your table of contents. Oh, this is for your notes. Now we're in the table of contents. So 1 here. So in your table of contents, 1 on the left of the red line. Right after the red line, you write the Real Number System Review. Write the date. And see how you can see the red line popping up at you from the back side? On the right side of that red line, write page 3-4. Now, there are going to be times where your page numbers may not be my page numbers. We're going to try to keep them all the same. Excuse me as I lose my voice. Okay? So now let's go back to the note page. And what we're going to do is take those Frere models that you have, and we're going to start filling them out. Okay? So what I'm going to do is go through the definitions that we're going to write in that upper left-hand corner. And then we're missing a number, so we're going to make sure that we get that number in there. So on our list, we're going to start with, well, let's just start with a definition. The real number system and we're not going to make a Frere model out of this one. We're just going to write this out. Whatever I write is what you write. This is in your homework now. And the real number system, because we really just talked about rationals yesterday, but we're throwing in one more guy to be the real number system. And basically, it's the set of rational and what's the other group of numbers that belong in the real number system? We talked about one leg of it. Now we have another half of it. Okay? It's not natural. That's part of the rationals that we talked about. Nico? Irrational. Set of rational and irrational numbers. So every number that you have studied falls under the real number system. There is one more system that you will learn, and it's called the imaginary system. And that's the one that allows you to take square roots of negatives. Okay? All right, so now what you guys are going to do is you're going to switch gears, and instead of writing in your spiral, what you're going to do is go to your Freire models. And we're going to start defining our words. Let's see, let's start with rational number. So I'm going to go over definitions here. You're going to do it straight on your Freire model. So in the center, rational number. And we're going to write that really good definition in the upper right-hand corner that a rational number is, and I'm going to write it, and you can change the words as you need it, the set of numbers that are written as ratios, and I'm going to take that word, I'm going to underline it, and I'm going to relate it back to the word itself. A rational number starts with the word ratio. A ratio is a way of comparing two numbers. A fraction is a way of comparing two numbers. So we have a lot of synonyms in our math class, okay? So the set of numbers that are written as ratios or fractions in the form A over B, where B cannot equal 0. Okay, now it's the longest definition, and you notice in your Freire model it's kind of small, so you're going to have to write in a little bit petite fashion to make it fill in. So this is going to be a little learning curve for some of you. I know you're big writers. You're going to have to learn in certain situations. I've got to write within a confined space. Okay, that also happens when we're taking tests where you're given X amount of room and you should be able to solve the problem in that X amount of room. Okay, all right. So that's going to be your first Freire model. So part of what you'll do tonight is make sure you fill in the other three categories. I'm going to tell you my hardest section to put something in is the fact section, okay, or characteristics. Because this is for this one, there are a ton of values that can go in here. So you can actually write quite a few facts. But when we get to the more specific ones, that's where it gets a little bit dicier. So let's talk about a whole number. So this is your next Freire model. This is the counting numbers, is how a lot of people refer to it. Starting with 0. When you're out in PE and they ask you to count off, you're not going half, 1 whole, 1 1/2. You don't do that. 0.25, 0.5, 0.75, 1. You don't do that. When we count 1, 2, 3, 4, or 0, 1, 2, 3, 4. Okay? So a whole number is the counting numbers, or whole numbers I should say, is the counting number starting with 0. So if you need to, in the characteristics or facts, I would write excludes fractions, excludes decimals, excludes negatives. That's what I would write for the facts or characteristics of a whole number. I'll write that in a different color. Okay, next one would be natural numbers. And those would be the, let's see how to say it. We'll do a really lame definition. Counting numbers beginning with 1. Now, natural numbers make sense to call them natural because when we naturally begin to count off, we naturally start at 1. Okay, you never say, okay, start counting off, and you don't go 0, 1, 2, 3. Okay, you naturally start with 1. And that's because 1 is an emphasized number from the very first time a kid starts talking about numbers, is the number 1. We don't talk about zeros for a while because 0 is a little bit, what do you mean 0 is nothing? If it's there, shouldn't it be something? No, it represents the absence of something. Okay? It's like the black hole of numbers, right? And then I would also do the same exclusion and say it excludes decimals, fractions, negatives, and what else would you write? What else does it exclude? 0. Okay, so you can add that as another exclusion. And so I'm going to abbreviate D, F, N, and 0. Okay. The next word we had was integers. You guys doing okay? Integers are whole numbers and their opposites. So that means 0 is part of it. And opposites is a very important word that we use in multiple situations throughout math. So we want to get used to using that word. Now, the exclusion would be the same as the exclusion, so the facts characteristics, you can say excludes the same thing as what's there for whole numbers. So my question is, what do I call negative 1/2? What do you call him? Integer. He's not an integer, because by definition, it's whole numbers and their opposites. But we think it because he's negative, but he's not. So what name do we give to negative 1/2? Bianca, what do you think? Oh, think. You got to think of something. Which one of these words that we've covered would negative 1/2 fall under? It's rational. Okay? Because rational is the big umbrella, right? He covers all sorts of stuff. It says a set of numbers that can be written as ratios or fractions in the form a over b where b doesn't equal 0. It doesn't mention anything about signs. So rationals can be positive or negative. They can be fractions. Okay? Now you might say, well, wait a second. How is 3 a rational number? It's not a fraction. Can I turn it into a fraction? Yes, I can. How do I turn it into a fraction? Lainey. You give it a denominator of 1. Okay? Again, you can change any decimal to a fraction, and you can change any fraction to a decimal. Okay, so you have the ability to flip things around, be flexible in your thinking. You guys should already know how to do that. Tomorrow we'll specifically talk about the how to do or repeating decimals. How do we take those and turn them into ratios? And we'll also talk about our other friend, who you guys didn't talk about, was the irrational number. So let's add one more vocab word. So I'm not going to do a vocab for terminating and repeating decimals, okay, because I think that one's pretty self-explanatory. So let's put in for irrational numbers. And this will be our last vocab word. So guess what goes into the group of irrational numbers? Michael. You forgot. I forgot. Okay. You can say this very generally. What's going to go on there? Johnny Ray? No, actually, he can't go into either because it doesn't exist.
Oh,
Yeah.
yeah.
He's not real.
Pi, irrational.
Okay, and what makes pi irrational and because I can write pi as a decimal. Why is it not considered rational? Why is it irrational? Joy? Actually, it's not repeating. That's kind of one of the weird things about pi. Pi is a decimal, but it doesn't meet the two criteria of a rational decimal. It doesn't, you help me out. It doesn't repeat, and it doesn't terminate. It's this thing that goes on forever, okay? Now, I'm going to give you the definition, and then we can add those two ideas into the characteristics, okay? So an irrational number, and this is going to sound kind of familiar to you, cannot, let's do it this way. A number that cannot, and I'm going to box that word not, be written as the ratio of two integers. And that makes me wonder if I forgot that piece back in our other definition, so we'll have to go back and check. So characteristics would be non-repeating, non-terminating decimals. Now, generally when we see rational numbers, we don't see them in that form. What form do we normally see a number that we go, oh, that's irrational? Jenny?
I was going to say fractions.
No, fractions, we don't normally see it like that. Other than giving me pi as an example, what's another example that would be considered irrational? So this is going to be the most common way that you would see a number being irrational outside of pi. Give you a hint. It involves this. What's that called? It's a square root symbol. What kind of numbers would go in the square root symbol and you go, irrational? Johnny?
Odd numbers.
Not odd numbers, because, let me think. That number's rational. Why? What's the square root of 121? It's 11. Can I write 11 as a fraction, the ratio of two integers?
Yeah.
It's rational. Okay. So what's an example where I can't do that? Jenny?
Prime numbers.
Okay, it could be prime numbers. Prime numbers aren't all that it is. It's just anything that's not a perfect square. So we'll get more into perfect squares tomorrow. Okay. So one thing I want to go back and look at and see rational set of numbers that can be written as the ratios or fractions in the form. Let's add something to this definition to rational. Form A over B, where B can't equal 0, and A and B are integers. And the reason why it's important for us to write this in is if you ever give me an answer of 2.5 over 6 and say it's a ratio, right? Therefore it's rational. It is not, because you cannot have a decimal inside of a fraction. So, and I've had multiple answers like that. I don't know where that thought comes from, but we need to make sure that it's an integer over an integer when we're talking about rational numbers. Okay, that's it for our part of our notes.